Question 1. For each statement below, indicate whether the answer is true or false. App service on Linux is unavailable in the shared pricing tier. True. The Azure portal displays all features for Linux apps, even if they aren't yet supported. False. Custom containers are required to deploy apps using unsupported runtimes. True. Disk latency is generally lower when using built-in images than when using container file systems. False. Now that we've gone through all the questions and their correct answers, let's take a moment to explain them clearly and step by step. To begin with, app service on Linux not being available in the shared tier is true because Linux-based plans require higher tier infrastructure, which the shared tier simply doesn't provide. Next, the idea that the Azure portal displays all Linux features regardless of support is false. Instead, the portal only surfaces features that are actually supported at that point in time, ensuring users don't attempt actions that would fail. Additionally, custom containers being required for unsupported runtimes is true, since they allow developers to package any runtime environment the platform doesn't natively offer, ensuring full flexibility. Finally, the statement about lower disk latency with built-in images is false because built-in storage volumes typically have higher and more unpredictable latency compared to container file systems, which benefit from their isolated and optimized storage layers. This way, each answer connects logically and helps reinforce how these platform behaviors impact real deployment scenarios. Question 2. A company deploys multiple web apps using the same shared infrastructure where resources are also used by other customers. They now want an environment where compute resources are fully dedicated to them for enhanced security and scalability. Which Azure service should they select? Select one answer. A. Virtual machine scale sets. B. Azure Functions. C. App Service on Linux. D. App Service Environment. Correct answer. D. App Service Environment. Now that we've gone through the question and identified the correct answer, let's move into the explanation. To begin with, an app service environment is designed to provide a fully isolated and dedicated hosting environment, making it ideal for organizations that want exclusive compute resources for enhanced security and predictable performance. Moreover, app service on Linux doesn't offer resource isolation because it only defines the OS layer, not the underlying infrastructure. Additionally, Azure Functions operate on a serverless model that scales on demand but doesn't guarantee dedicated compute resources. Finally, virtual machine scale sets focus on provisioning and scaling virtual machines, which differs from the PaaS environment the company requires for hosting web apps. Altogether, these points clearly show why the app service environment is the only option that delivers the dedicated and isolated compute environment the company is looking for. Question 3. Fill in the blanks by selecting the correct options from the drop-down menus. All apps within the same app service plan share the same VM instances, and the plan itself acts as the scale unit for those apps. Now that we've read the question and the correct answers, let's move smoothly into the explanation. To start, apps in an app service plan all run on the same set of virtual machine instances, which means they share the same compute resources regardless of how many apps you deploy on that plan. Consequently, the plan operates as the scale unit because scaling doesn't happen per app. Instead, it happens at the plan level, determining how many instances are available for all apps collectively. Additionally, this setup makes scaling predictable since increasing the number of VM instances automatically boosts capacity for every app under that plan. Altogether, understanding this relationship helps ensure proper planning when hosting multiple applications on a single app service plan to avoid resource contention and unexpected performance issues. Question 4. For each Azure App Service authentication concept, drag it to the appropriate description in the correct match column. Authenticates users and clients with the specified identity provider. Authentication middleware. Manages the authenticated session. Session management. Validates, stores, and refreshes OAuth tokens issued by the configured provider. Token handling. injects identity information into HTTP request headers. Identity injection. Now that we've reviewed all the items and their correct matches, let's transition into the explanation. To begin with, authentication middleware is responsible for verifying users and clients by communicating with the chosen identity provider before any request reaches the app, ensuring only authenticated traffic gets through. After authentication, session management takes over by maintaining the user's active session so they can continue accessing the app without repeatedly signing in. Next, token handling plays a crucial role because it validates, stores, and refreshes OAuth tokens issued by identity providers, which is essential for secure and uninterrupted access to protected resources. Finally, identity injection inserts user identity details into HTTP request headers, allowing the application code to recognize who the authenticated user is and apply the appropriate logic. Altogether, these components work together to create a complete and secure authentication flow for Azure App Service applications, each handling a distinct but interconnected part of the process. Question 5. A developer is deploying a Windows-based application to Azure App Service and needs the platform to correctly process requests for files with the .php extension. The application includes its own PHP processor located at d-home site www.php-cgi.exe, and the developer must configure the app service to route all .php requests to this executable. What should the developer configure? Select one answer. A. Add a new handler mapping with the .php extension and specify the script processor path d-home site wroot.cg.exe. B. Add a new virtual directory and set its path to PHP. C. Add a new Azure storage mount for PHP processor files. D. Use an advanced storage configuration with Key Vault credentials. Correct answer, A. Add a new handler mapping with the PHP extension and specify the script processor path, dhppc.exe. Now that we've gone through the question and selected the correct answer, let's transition into the explanation. First, adding a handler mapping is essential because Windows-based Azure App Service uses handler mappings to associate specific file extensions with the executable that should process them, which means all .php requests can be routed directly to the PHP processor located in the app's directory. In contrast, creating a virtual directory doesn't help here, since virtual directories are only used to remap content paths, not to define how file extensions should be executed. Furthermore, Azure storage mounts are designed for containerized or scalable content storage and have nothing to do with how IIS processes script extensions. Lastly, advanced storage configurations with Key Vault credentials relate to secure storage access, not to script processing or handler definitions. Altogether, using a handler mapping is the only configuration that correctly instructs the platform to process .php requests using the provided PHP executable. Question 6. For each statement below, indicate whether the answer is true or false. Application logging is supported on both Windows and Linux App Service apps. True. Web server logging is supported on Linux and Windows equally. False. Detailed error messages can be saved in production for client visibility. False. Failed request tracing produces one folder per failed request. True. Now that we've reviewed all the statements and their correct true or false answers, let's ease into the explanation. To start, application logging is indeed available in both Windows and Linux App Service environments, allowing developers to capture custom logs regardless of the hosting OS. However, web server logging differs because it's only supported on Windows, meaning Linux App Service apps cannot generate traditional web server logs. Moreover, detailed error messages should never be exposed to clients in production. Instead, they're stored securely for internal review to prevent accidental disclosure of sensitive information. Finally, failed request tracing creates a dedicated folder for every failed request, and each folder contains XML and XSL trace files that help diagnose issues in the request pipeline. Altogether, these distinctions highlight how logging and diagnostics differ across platforms, and why each feature must be used correctly for secure and effective troubleshooting. Question 7. Arrange the following phases of a slot swap operation in the correct order. Apply target slot settings to source slot, restart all source slot instances, warm up source slot, trigger HTTP requests, swap routing rules to redirect traffic, apply target slot's previous app to source slot and restart. Now that we've read all the steps in the correct sequence, let's move into the explanation. First, Azure begins the swap by applying the target slot's configuration settings to the source slot, so the app can run with production-ready settings before going live. Next, the platform restarts all source slot instances to initialize the app under the updated configuration and ensure everything loads cleanly. After the restart, Azure warms up the source slot by sending HTTP requests, allowing the app to be fully operational and responsive before traffic is routed to it. Once the warm-up is complete, Azure swaps the routing rules so production traffic now flows to the newly prepared slot. Finally, the platform updates the non-production slot by applying the previous version of the target slot's app back to the source slot and restarting it, completing the swap cycle. Altogether, this structured sequence ensures zero downtime transitions and smooth production rollouts during slot swaps. Question 8. Fill in the blanks by selecting the correct options from the drop-down menus. To enable auto swap, navigate to the Configuration General Settings page of the selected deployment slot, set auto swap enabled to on. Choose the target slot, and select Save. Now that we've gone through the sentence and identified the correct options, let's walk through the explanation. First, auto swap is configured through the Configuration General Settings section, because that's where deployment slot behavior and runtime settings are managed in Azure App Service. Next, turning auto swap to on is what activates the automatic swapping process whenever a new deployment is made to the slot. After that, choosing the target slot is essential since this determines which slot will receive the updated app after every swap operation, typically the production slot. Finally, selecting Save commits the configuration so the auto swap behavior becomes active and applies to future deployments. Altogether, these steps ensure that deployments can move smoothly from a staging slot into production without manual intervention, improving release speed and consistency. Question 9. Which tagging practice is recommended when building container images for continuous deployment? Select one answer. A. Avoid tagging altogether to reduce pipeline complexity. B. Reuse the same tag for every environment. C. Tag each image with a unique identifier such as commit ID or timestamp. D. Always use the default latest tag for all builds. Correct answer. C. Tag each image with a unique identifier such as commit ID or timestamp. Now that we've reviewed all the options and selected the correct answer, let's move into the explanation. First, tagging container images with unique identifiers such as commit IDs or timestamps is essential because it allows teams to trace exactly which version of the code is deployed at any moment, making debugging and rollbacks far easier. In contrast, using the default latest tag for all builds creates confusion since it hides which specific version is running, especially across different environments. Similarly, reusing the same tag for every environment removes visibility between staging and production builds, making it difficult to ensure that what was tested is exactly what is being released. Finally, avoiding tagging altogether eliminates traceability entirely, which is a major issue for continuous deployment where rapid iterations require clear version tracking. Altogether, using unique tags ensures clarity, accountability, and smoother deployment workflows in modern container-based development pipelines. Question 10. What best describes the difference between server flow and client flow in Azure App Service authentication? Select one answer. A. Server flow is for REST APIs only, client flow for browsers. B. Server flow requires SDK integration, client flow does not. C. Server flow and client flow are identical authentication processes. D. Server flow delegates sign-in to app service, client flow manages sign-in using provider SDKs. Correct answer, D. Server flow delegates sign-in to app service, Client Flow manages sign-in using provider SDKs. Now that we've reviewed all the options and identified the correct answer, let's shift into the explanation. To begin with, Server Flow hands control of the authentication process to app service itself, meaning the platform manages redirection, sign-in, and token handling on behalf of the application, which simplifies integration for server-rendered apps. Conversely, Client Flow places responsibility on the application code by requiring the use of identity provider SDKs, such as MSAL or OAuth libraries, allowing the app to directly manage user sign-in and token acquisition on the client side. Additionally, this distinction is important because the two flows serve different architectural needs. Server Flow is ideal for traditional web apps, whereas Client Flow suits SPAs and mobile apps, where authentication must happen within the client environment. Altogether, this difference highlights how app service supports multiple authentication patterns depending on where sign-in logic should live and how much control the developer wants over the process. Question 11. When stored in Azure App Service, how are application settings protected? Select one answer. A. They are stored in plain text for faster access. B. They are encrypted at rest. C. They are encoded but not encrypted. D. They rely solely on user-managed encryption keys. Correct answer? B. They are encrypted at rest. Now that we've read all the options and selected the correct one, let's move into the explanation. To begin with, Azure automatically encrypts all app service application settings at rest, ensuring sensitive values like connection strings and secrets are fully protected without requiring any manual configuration. In contrast, plaintext storage is never used because it would expose confidential data directly, which Azure strictly avoids. Likewise, encoding is not the same as encryption. Encoding only transforms data for formatting purposes and provides no security, so that option cannot describe how settings are protected. Finally, App Service does not rely solely on user-managed keys, because Azure-managed encryption keys handle the default encryption process automatically, giving users secure protection out of the box. Altogether, this automatic encryption mechanism ensures that application settings remain safe even if someone gains unauthorized access to underlying storage. Question 12. Which option for application logging Windows should be used for long-term storage? Select one answer. A. Failed request tracing. B. Web server logging, file system. C. Application logging, file system. D. Application logging blob. Correct answer. D. Application logging blob. Now that we've read all the options and selected the correct one, let's move into the explanation. To begin with, application logging using blob storage is the recommended choice for long-term retention because it stores logs persistently in Azure storage containers, allowing developers to archive, query, and access historical logs whenever needed. In contrast, application logging on the file system is only meant for short-term debugging since it automatically disables itself after 12 hours, making it unsuitable for ongoing retention. Additionally, web server logging on the file system focuses on HTTP request data, not application-level information, so it doesn't meet the need for comprehensive application log storage. Finally, failed request tracing is designed specifically for diagnosing failed HTTP requests, and not for general log persistence, which limits its usefulness for long-term logging strategies. Altogether, blob-based application logging provides the durability and reliability required for maintaining logs over extended periods. Question 13. An application owner needs to deploy a certificate that can be automatically renewed and seamlessly synchronized across multiple Azure App Service applications without requiring manual renewal or redistribution steps. Which certificate option should they use? Select one answer. A. Use an App Service certificate purchased from Azure. B. Create a free App Service managed certificate. C. Upload a private certificate from a third-party provider. D. Import a public certificate. Correct answer. A. Use an App Service certificate purchased from Azure. Now that we've gone through the question and identified the correct answer, let's move into the explanation. To begin with, an app service certificate purchased directly from Azure is designed for full automation. Azure handles the purchase, verification, renewal, and synchronization across all linked app service apps, meaning the owner never has to manually renew or redistribute it. In contrast, free app service managed certificates can auto-renew, but they aren't synchronized across multiple apps, so they don't meet the requirement for seamless multi-app integration. Meanwhile, uploading a private certificate from a third-party provider introduces manual renewal and manual redistribution steps, which goes directly against the goal of automation. Finally, importing a public certificate doesn't provide domain security or automatic lifecycle management, so it would also fail to meet the stated requirement. Altogether, using an Azure-purchased app service certificate is the only option that delivers automatic renewal and synchronized distribution with no manual involvement. Question 14. How can you make an autoscale condition perform a scale-in action when any one of its scale-in rules is met? Select one answer. A. Create separate autoscale conditions for each scale-in rule. B. Set the cooldown period to 0. C. Use an OR operator between rules. D. Combine all metrics into one rule. Correct answer. A. Create separate autoscale conditions for each scale-in rule. Now that we've reviewed all the options and selected the correct answer, let's move into the explanation. To begin with, Azure's autoscale engine requires all scale-in rules inside a single condition to be true at the same time before it triggers a scale-in, which means the logic naturally works as an AND relationship. Therefore, the only way to make the platform react when any individual rule is met is to separate those rules into their own autoscale conditions, allowing each one to trigger scaling independently. Meanwhile, setting the cooldown period to 0 doesn't change the rule logic. It only affects how frequently scaling can occur. Additionally, Azure doesn't support inserting custom OR operators between rules, so that option isn't possible. Finally, combining all metrics into one rule wouldn't work because each autoscale rule evaluates a single metric, and merging them removes the ability to check distinct scale-in conditions. Altogether, creating separate autoscale conditions ensures that a single rule can trigger a scale-in action without requiring the others to be true at the same time. Question 15. A development team releases a new version of an app, but wants only 20% of users to access it for early feedback, while 80% continue using the current production version. What should they configure? Select one answer. A. Set a traffic percentage of 80% for the staging slot in the configuration settings. B. Set a traffic percentage of 20% for the staging slot in the deployment slots page. C. Modify the app's web.config file to include a 20% routing rule. D. Enable MS routing to enable staging for all sessions. Correct answer, B. Set a traffic percentage of 20% for the staging slot in the deployment slots page. Now that we've gone through the question and select the correct answer, let's move into the explanation. To start, the deployment slots page includes a dedicated traffic percent column, which allows teams to specify exactly what portion of incoming requests should be routed to a non-production slot, such as staging. Setting it to 20% ensures only a small, controlled group of users reaches the new version. Meanwhile, setting traffic percentages in configuration doesn't work because routing rules are not managed there. They're only configured on the deployment slots page. Additionally, modifying the app's web.config to enforce routing wouldn't affect slot-based traffic because app service handles routing at the platform level, not inside application code. Lastly, enabling XMS routing name = staging by default would force all sessions into the staging slot, which removes the ability to route only a targeted percentage of users. Altogether, configuring the staging slot to receive 20% of traffic directly in the deployment slots page is the correct and simplest way to run A/B-style testing with controlled exposure. Question 16. Fill in the blanks by selecting the correct options from the drop-down menus. During platform updates or scaling operations, The premium and flex consumption plans allow a 60-minute grace period for in-progress executions, while the dedicated plan provides a 10-minute grace period. Now that we've read the completed sentence with all correct selections, let's move into the explanation. To begin with, both premium and flex consumption plans offer a generous 60-minute grace period, which allows any ongoing executions to finish before the platform completes a scale-in or maintenance event. This ensures workloads aren't abruptly interrupted and helps maintain application reliability during transitions. Meanwhile, the dedicated plan provides a shorter 10-minute grace period, which still allows some buffer for running tasks to complete, but doesn't offer the extended protection found in premium or flex consumption options. Furthermore, these grace periods are especially important for long-running or stateful workloads where abrupt termination could lead to failed operations or inconsistent data. Altogether, understanding these timing windows helps developers choose the right hosting plan based on how sensitive their executions are to interruptions during platform operations. Question 17. A global e-commerce company wants to host its function apps in a plan that can manually scale to 100 instances for secure, high-memory operations inside an isolated network environment. Which plan meets this requirement? Select one answer. A. Consumption plan. B. Dedicated plan. C. Premium plan. D. Container apps. Correct answer B. Dedicated plan. Now that we've gone through the question and selected the correct answer, let's move into the explanation. To begin with, the dedicated plan running inside an app service environment is the only option that supports manual scaling up to 100 instances while also providing full isolation and high memory capabilities. This makes it ideal for organizations that require strict network boundaries and predictable performance. In contrast, the consumption plan has hard limits of 100 or 200 instances depending on the operating system, and it doesn't provide network isolation. Meanwhile, the premium plan is event-driven and does not support the same isolated ASE deployment model needed for fully secure environments. Lastly, container apps scale by replicas, but do not use the app service instance model, and they don't fulfill the requirement for manual ASE-based scaling. Altogether, the dedicated plan in an isolated ASE environment is the only configuration that satisfies high memory needs, strict isolation, and scaling up to 100 instances. Question 18. For each statement below, indicate whether the answer is true or false. A function app enforces a single runtime version across all contained functions. True. Each function in a function app can use its own deployment pipeline. False. All functions within a function app share the same pricing plan. True. Functions within the same app must all use different runtime versions. False. Now that we've gone through the statements and their correct true or false answers, let's move into the explanation. To start, a function app always enforces one unified runtime version, meaning every function inside it runs on the same underlying runtime, which keeps the app consistent and stable. However, individual functions cannot have separate deployment pipelines because deployments apply to the function app as a whole, not to each function independently. Additionally, all functions within a function app share the same pricing plan since the plan is assigned at the app level, and billing is based on the function app, not individual functions. Finally, functions do not use different runtime versions. The runtime is shared across the entire app, so mixing versions isn't possible. Altogether, these rules help ensure predictable behavior, consistent runtime execution, and a unified deployment model for every function app. Question 19. Which statement accurately describes the relationship between triggers and bindings in Azure Functions? Select one answer. A. A function can have multiple triggers, but only one binding. B. A function must have at least one binding but no trigger. C. Triggers and bindings serve the same purpose in Azure Functions. D. A function must have exactly one trigger and can have 0 or more bindings. Correct answer, D. A function must have exactly one trigger and can have 0 or more bindings. Now that we've reviewed all the options and selected the correct answer, let's move into the explanation. To begin with, every Azure function requires exactly one trigger, because the trigger determines how and when the function is invoked, whether through an HTTP request, a queue message, a timer, or another event source. Meanwhile, bindings are optional and can be added as needed to connect the function to input or output data sources, such as storage, events, or databases. A function may have 0, 1, or multiple bindings depending on its purpose. Additionally, functions cannot have multiple triggers because having more than one trigger would create ambiguity around invocation flow and execution conditions. Finally, triggers and bindings are not interchangeable. Triggers initiate execution, while bindings facilitate data movement in or out of the function. Altogether, this model ensures clear invocation logic while providing flexible integration with other Azure services through bindings. Question 20. For each statement below, indicate whether the answer is true or false. The in-out binding direction supports reading and writing to the same resource. True. The in-out direction can be configured in the Standard Integration tab for all bindings. False. When using inout, only the advanced editor is available for editing. True. In-out is a valid direction for triggers. False. Now that we've read through all statements along with their correct true or false answers, let's move into the explanation. To begin with, the in-out direction is indeed valid for compatible bindings because it enables bidirectional data flow, allowing a function to read from and write back to the same resource in a single operation. However, this direction cannot be set through the Standard Integration tab, since the basic UI doesn't expose in-out as an option. Instead, developers must edit the function.json file directly or use the advanced editor. Additionally, modifying in-out properties requires switching to the advanced editor mode, which provides full JSON-level access to binding configuration that isn't available in the simplified interface. Finally, in-out cannot be used for triggers because triggers only use the in direction. They are meant to start the function, not send data back to the triggering source, so in-out applies exclusively to bindings. Altogether, these distinctions highlight how in-out behaves differently from standard binding directions and why advanced editing is often required to configure it properly. Question 21. For each statement below, indicate whether the answer is true or false. Blob storage is used only for structured data. False. The hot tier has the lowest storage cost. False. False. Data in the archive tier can take several hours to retrieve. True, you can change a blob's access tier at any time. True. Now that we've reviewed all statements and their correct true or false answers, let's move into the explanation. To begin with, blob storage is designed for unstructured data, such as text, binary files, images, and logs, so it's incorrect to say it only stores structured data. Next, the hot tier actually has the highest storage cost because it's optimized for frequent access, while cooler tiers cost less to store data but more to retrieve it. Meanwhile, archive tier data can indeed take hours to rehydrate before it becomes accessible, which is why it's used for long-term, rarely accessed information. Finally, Azure allows you to switch a blob's access tier whenever needed, giving flexibility to adapt to changes in data usage patterns over time. Altogether, these differences help organizations choose the right access tier based on how often data needs to be retrieved and how much they want to spend on storage versus access costs. Question 22. Your team creates a storage account named Media Archive to store video content in Azure Blob Storage. Developers need to determine the full base endpoint for accessing blobs in this account. Which of the following correctly represents the base address? Select one answer, mediaarchive.azurewebsites.net, B, http://mediaarchblob.core.windows.net /azure.blob.mediaarchive.net, ds/mediaarchive.core.windows.blob. Correct answer, B, mediaarchive.blob.core.windows.net. Now that we've reviewed the options and identified the correct answer, let's move into the explanation. To begin with, every Azure storage account forms its blob endpoint using the format http:/accountname.blockcore.windows.net, which means combining the storage account name with the Azure Blob domain. In this case, the account name is Media Archive, so the correct base endpoint becomes mediaarchive.blob.core.windows.net, matching option B exactly. Meanwhile, option A points to an Azure App Service domain, which is used for web applications and not for storage accounts. Option C uses an incorrect domain order, placing the account name at the end, which doesn't follow Azure's required structure. Lastly, option D reverses the necessary domain segments, making it invalid because blob.core.windows.net must remain in its fixed order. Altogether, the correct blob storage base address is the one that follows Azure's precise domain format, which is mediaarchive.blob.core.windows.net. Question 23. For each Azure Storage Encryption Key Management option, drag it to its correct description in the correct match column. Uses keys stored in Azure Key Vault or Key Vault HSM for blob and file storage encryption. Customer managed keys. Encryption and decryption fully handled by Azure using Microsoft's Key Store. Microsoft Managed Keys allows a client to supply its own key on a per-operation basis for blob storage. Customer-provided keys. Now that we've reviewed all items and their correct matches, let's move into the explanation. To begin with, customer-managed keys give organizations direct control by storing keys inside Azure Key Vault or a Key Vault HSM, allowing them to manage rotation, lifecycle, and auditing with a high degree of security oversight. Meanwhile, Microsoft Managed Keys represent the default model, where Azure transparently stores and rotates the encryption keys on behalf of the customer, requiring no administrative effort. Additionally, customer-provided keys allow clients to supply their own encryption key with each blob request, enabling fine-grained control for scenarios where per-operation encryption is needed. Shared access signatures and storage access policies don't appear in the matches because they relate to permission management, not encryption key handling. Altogether, these key management options give organizations flexibility in choosing how much control and responsibility they want over their Azure storage encryption. Question 24. Which programming languages are supported by Azure Storage client libraries for performing client-side encryption? Select 3 answers. A. Net, B. Python, C. Java, D. JavaScript. Correct answers. A. Net, B. Python, C. Java. Now that we've reviewed all the options and identified the correct 3 answers, let's move into the explanation. To begin with, Azure provides full client-side encryption support in its .NET SDK, allowing applications to encrypt and decrypt data locally before sending it to storage. Similarly, the Python SDK includes the necessary encryption libraries, making it easy for developers to secure data on the client side before upload. Additionally, the Java client library mirrors the .NET capabilities, offering built-in client-side encryption features for blob and queue storage. However, the JavaScript SDK does not currently support client-side encryption for Azure Storage, meaning developers using JavaScript must rely on other encryption mechanisms outside of the official SDK. Altogether, only .NET, Python, and Java support native client-side encryption within the Azure Storage SDK ecosystem. Question 25. Fill in the blanks by selecting the correct options from the drop-down menus. Lifecycle management rules can filter data using blob index tags, or name prefixes, to apply transitions or deletions only to specific subsets of blobs. Now that we've reviewed the completed statement with the correct drop-down values, let's move into the explanation. To begin with, blob index tags allow conditional filtering based on metadata labels, which gives you the flexibility to apply lifecycle actions only when certain tag conditions are met. Meanwhile, name prefixes help group blobs by naming convention, making it easy to apply lifecycle rules to entire folders or categories of blob names without handling them individually. Additionally, using these filters ensures that transitions or deletions only affect specific subsets of blobs rather than the entire storage account, which is vital for managing different data retention needs. Altogether, these filtering capabilities make lifecycle management far more precise and help organizations automate retention, archiving, and cleanup processes efficiently. Question 26. A storage administrator wants to automate the creation of lifecycle policies as part of deployment scripts. The policy definitions are stored as JSON files. Which method should they use? Select one answer. Azure Portal, B, Azure CLI, C, Azure Policy, D, Azure Data Explorer. Correct answer, B. Azure CLI. Now that we've gone through the question and selected the correct answer, let's move into the explanation. To begin with, the Azure CLI is the only option that supports creating and managing lifecycle policies directly from JSON files, making it ideal for automation inside deployment pipelines or scripts. Commands such as AZ Storage Account Management Policy Create allow administrators to apply JSON-based configurations consistently and efficiently. In contrast, the Azure portal is designed for manual configuration, which isn't suitable when automation is required. Additionally, Azure Policy focuses on compliance enforcement across resources and doesn't manage blob lifecycle configurations, so it cannot be used for this scenario. Lastly, Azure Data Explorer is an analytics service and has no capability for storage policy management. Altogether, using the Azure CLI ensures lifecycle policies can be deployed automatically, consistently, and repeatedly as part of an infrastructure as code workflow. Question 27. Arrange the following steps to add a lifecycle management policy using Azure Portal Code View in the correct order. Navigate to the storage account in Azure Portal. Select Lifecycle Management under Data Management. Open the Code View tab. Define or paste the JSON policy. Save the changes. Now that we've listed all steps in the correct order, let's move into the explanation. To begin with, you first navigate to the storage account because all lifecycle configurations live within the account's management blade. Next, selecting Lifecycle Management under Data Management brings you to the section where policies can be viewed or modified. After that, opening the Code View tab is necessary because it exposes the raw JSON editor, which allows more precise control over policy definitions. Then, defining or pasting the JSON policy sets the actual rules that dictate how data transitions or deletions occur over time. Finally, saving the changes commits the policy to the storage account so Azure can begin enforcing the lifecycle actions. Altogether, these steps reflect the clear and sequential workflow required to manage lifecycle rules through the Azure portal. Question 28. Fill in the blanks by selecting the correct options from the drop-down menus. When creating an Azure Cosmos DB container, a partition key must be supplied so that data can be distributed efficiently across partitions. The platform uses the value of this property to route items to the appropriate partition when they are written, updated, or deleted. And the same property can be used in the where clause of queries for efficient retrieval. Now that we've reviewed the full sentence with the correct options, let's move into the explanation. To begin with, the partition key is the core property Azure Cosmos DB uses to group items into logical partitions, ensuring that data is distributed and accessed efficiently across the underlying infrastructure. Next, data is spread across multiple partitions, and the partition key determines exactly which partition each item belongs to, helping Cosmos DB scale horizontally. Additionally, when items are written, updated, or deleted, Cosmos DB relies on the partition key value to route the operation to the correct partition, keeping access fast and consistent. Finally, using the partition key in the where clause of queries ensures that Cosmos DB can quickly target a specific logical partition, significantly improving query performance. Altogether, understanding how the partition key drives distribution, routing, and querying is essential for designing efficient and scalable Cosmos DB solutions. Question 29. A development team is building a .NET application that interacts heavily with Azure Cosmos DB. The application will create and read items frequently and must maintain optimal performance while handling many concurrent operations. The team is unsure how to manage connections and considers creating a new Cosmos client instance every time they access the database. Would this approach meet the performance needs of the application? Select one answer. A. Cosmos client should only be created once per container access. B. Multiple Cosmos client instances reduce overhead in high-traffic apps. C. Using a single Cosmos client instance improves performance because it is thread-safe. D. Creating a new Cosmos client instance for each operation increases performance. Correct answer. C. Using a single Cosmos client instance improves performance because it is thread-safe. Now that we've reviewed all the options and identified the correct answer, let's move into the explanation. To begin with, the Cosmos client is designed to be thread-safe, meaning a single instance can safely handle many concurrent requests across the entire application without creating conflicts or bottlenecks. Because of this, reusing one instance avoids unnecessary connection overhead and reduces resource consumption. In contrast, creating a new Cosmos client for each operation forces the system to reestablish connections repeatedly, which significantly degrades performance and increases latency. Meanwhile, trying to use multiple Cosmos client instances in high-traffic workloads doesn't help either, because each instance incurs its own initialization costs and leads to inefficient connection management. Finally, the best practice is to create one Cosmos client instance per application, not per container, ensuring consistent performance and optimal use of resources. Altogether, maintaining a single shared Cosmos client instance is the most efficient and scalable approach for applications with heavy and frequent Cosmos DB interactions. Question 30. For each statement below, indicate whether the answer is true or false. Stored procedures can create, read, update, query, and delete items within an Azure Cosmos container. True. Stored procedures are registered globally and can operate across all containers. False. A stored procedure must be registered before it can be called. True. Arrays passed as parameters are automatically recognized as arrays within the stored procedure. False. Now that we've reviewed the statements and their correct true or false answers, let's move into the explanation. To begin with, stored procedures in Cosmos DB can perform all CRUD operations because they execute within the same partition and have full access to the data through the JavaScript context object. However, stored procedures are not registered globally. They are registered per container, meaning each container has its own set of stored procedures, and they cannot operate across containers. Additionally, a stored procedure must be registered before it can be called. Otherwise, the client has no reference to invoke it. Finally, arrays passed in as parameters aren't automatically treated as arrays inside the stored procedure. They arrive as strings and must be manually parsed into array structures. Altogether, understanding how stored procedures are scoped and how they handle parameters is essential for designing reliable, partition-aware operations in Cosmos DB. Question 31. Which statement accurately describes how triggers are executed in Azure Cosmos DB? Select one answer. A. Post triggers only execute when the database starts up. B. Pre-triggers always run before and after item modifications. C. Triggers are automatically applied to every insert and update in a container. D. Triggers must be explicitly specified for each operation. They aren't executed automatically. The correct answer is D. Triggers must be explicitly specified for each operation. They aren't executed automatically. Now that we've reviewed all the options and stated the correct answer, let's move into the explanation. To begin with, Cosmos DB does not run triggers by default. Each trigger must be explicitly attached to the exact operation where you want it to execute, which is why option D is accurate. Moreover, pre-triggers do not run before and after modifications. They only run beforehand, so option B doesn't hold up. Additionally, post triggers aren't linked to database startup events. They run immediately after the operation they're associated with, which rules out option A. And finally, triggers are never automatically applied to inserts or updates. Cosmos DB requires you to specify them manually in the request, making option C incorrect. Altogether, this controlled execution model ensures that triggers only run when intentionally invoked, preventing unexpected behavior during data operations. Question 32. When defining a trigger in Azure Cosmos DB, which statement is true about its operation scope? Select one answer. A. It automatically applies to all container operations once registered. B. It must be registered to run with specific operations such as create, replace could, or delete. C. It runs only during metadata updates. D. It requires the multiple operation types to register successfully. The correct answer is B. It must be registered to run with specific operations such as create, replace, or delete. Now that we've reviewed all the options and stated the correct answer, let's move into the explanation. To begin with, triggers in Cosmos DB never apply automatically across all container operations. Each one must be explicitly tied to a specific action, such as create, replace, or delete. Furthermore, Cosmos DB uses this registration to determine exactly when the trigger should fire, giving developers precise control instead of global or automatic behavior. Additionally, triggers aren't limited to metadata updates. They can respond to actual data operations, which rules out option C. And lastly, a trigger doesn't require multiple operation types to register. It can be bound to just one, making option D incorrect. Altogether, this means that a Cosmos DB trigger takes effect only when you explicitly bind it to a particular operation type, ensuring predictable and intentional execution behavior. Question 33. An application needs to react in real time whenever items in an Azure Cosmos DB container are inserted or updated. The team wants automatic scaling, reliable event delivery, and no manual polling. Which approach best meets these needs? Select one answer. A. Manually poll the container using the poll model in custom code. B. Use Azure functions with a Cosmos DB trigger to process the change feed. C. Query the container periodically with SQL queries. D. Add a post trigger to detect item changes. The correct answer is B. Use Azure functions with a Cosmos DB trigger to process the change feed. Now that we've reviewed all the choices and stated the correct answer, let's move into the explanation. To begin with, Azure functions integrated with a Cosmos DB trigger automatically listen to the change feed, allowing the system to react instantly whenever a new item is inserted or updated. Moreover, this approach removes the need for manual polling and offers automatic scaling, ensuring that the application can handle spikes in data volume without manual intervention. Meanwhile, periodically querying the container using SQL doesn't track changes incrementally and would introduce unnecessary overhead, making option C impractical. Additionally, manually polling the container requires custom code and constant management of state, which conflicts with the requirement for no manual polling, ruling out option A. Finally, post triggers only run after a specific database operation, but don't provide a scalable, continuous feed of changes. So option D doesn't satisfy the need for reliable event delivery. Altogether, the Cosmos DB trigger inside Azure Functions offers the most efficient, scalable, and real-time solution for reacting to item changes without manual work. Question 34. Fill in the blanks by selecting the correct options from the drop-down menus. In the push model, the change feed processor pushes work to a client that contains business logic for processing each batch of changes. Now let's explain it. In the push model, the change feed processor sends batches of changes directly to a client, which is the component responsible for performing the actual work. That client then runs its business logic, meaning the custom code that processes each set of incoming changes. Meanwhile, structures like the monitored container or lease container do not execute logic. They only support the underlying mechanics of the change feed. And metadata or partition key values play no role in executing processing logic, which is why they don't fit this scenario. Altogether, the flow reflects a typical push architecture. The processor assigns batches to clients, and those clients run custom business logic to handle each one. Question 35. The API that first receives newly released Azure Cosmos DB features before any other API is called what? Select one answer. A. API for Cassandra. B. API for NoSQL. C. API for Table. D. API for PostgreSQL. The correct answer is B. API for NoSQL. Now let's explain it. The API for NoSQL is the native and fully managed interface of Azure Cosmos DB, so it always receives new capabilities and performance improvements first. On the other hand, the API for Cassandra uses a wire protocol compatible layer, meaning it relies on translation and does not get features before the native API. Similarly, the API for Table focuses on key value operations and does not receive the newest Cosmos DB capabilities ahead of NoSQL. And the API for PostgreSQL is a different managed service entirely, so it does not participate in Cosmos DB feature rollouts. Altogether, the API for NoSQL is consistently the earliest recipient of new platform features. Question 36. Which two behaviors apply to delete container async? Select two answers. A. It requires an item response parameter to execute. B. It removes the container asynchronously. C. It deletes all items stored in the container. D. It preserves item metadata after deletion. The correct answers are B and C. Now let's explain it. Delete container async performs the removal using an async operation, so the deletion happens without blocking, which aligns with option B. Additionally, removing a container wipes out all items stored inside it, meaning nothing remains once the container is deleted, making option C correct. Meanwhile, metadata is not preserved after deletion. Once the container is removed, all associated item metadata is gone, so option D is incorrect. Finally, the delete operation does not require an item response parameter, which rules out option A entirely. Altogether, the method both deletes the container asynchronously and removes every item inside it. Question 37. An organization hosts its container registry in a single Azure region and wants it to remain accessible even if the entire region fails. Which feature best meets this requirement? Select one answer. A. Increase the number of repositories in the registry. B. Use customer-managed keys for encryption. C. Delete unused tags to improve performance. D. Enable geo-replication on the registry. The correct answer is D. Enable geo-replication on the registry. Now let's explain it. Geo-replication copies the registry to multiple Azure regions, keeping it accessible even if one region goes down, making it the only option that ensures regional resilience. Meanwhile, increasing repositories doesn't provide redundancy. It only adds more logical storage, so option A doesn't solve the outage issue. Customer-managed keys only strengthen encryption, but offer no protection against regional failure, so option B is irrelevant to availability. Deleting unused tags may help performance and reduce clutter, but it has nothing to do with failover or keeping the registry online, so option C is also not suitable. Altogether, enabling geo-replication is the only option that ensures the registry stays available during a full region outage. Question 38. A company creates an Azure container registry in a region that participates in Azure's paired region model. They do not enable geo-replication. They later discover that Azure is storing copies of their registry data in a second region within the same geography, even though they did not explicitly configure replication. Which reason best explains this behavior? Select one answer. A. Zone redundancy automatically copies data to paired regions. B. Azure may store registry data in a paired region for data protection. C. Customer-managed keys require data to be stored in two regions. D. The registry is automatically converted to geo-replicated storage. The correct answer is B. Azure may store registry data in a paired region for data protection. Now I'm going to explain why. In some Azure geographies, the platform automatically stores registry data in the paired region so that durability requirements are met. This happens even when you do not manually turn on geo-replication. Because of this built-in behavior, the registry can still benefit from resilient storage without any extra configuration. Meanwhile, zone redundancy does not copy data across regions. It only spreads data across availability zones inside the same region, so it cannot explain cross-region storage. Similarly, customer-managed keys only add encryption control, not data duplication. And automatic conversion to geo-replicated storage never occurs, because geo-replication must always be enabled manually. Therefore, the unexpected extra copy is simply Azure protecting the registry by storing data in its paired region. Question 39. For each statement below, indicate whether the answer is true or false. Quick tasks can build and push a container image without a local Docker engine. True, a base image trigger rebuilds application images when the application code changes. False, ACR tasks can track source code stored in a Git repository. Timer triggers can only execute a task once per day. False. Now that we've gone through all the questions and their correct answers, let's take a moment to explain how each one works. Quick tasks run entirely in Azure, so they don't rely on Docker being installed locally. This makes them extremely convenient for fast builds or automation scenarios. Meanwhile, a base image trigger doesn't watch your application code. Instead, it reacts when the base image itself is updated. For example, if a security patch is pushed to an Ubuntu base image, Azure can automatically rebuild your dependent image. Next, ACR tasks can absolutely track Git repositories. They can monitor branches or tags, pull in the latest changes, and then run tasks based on new commits, making continuous integration much easier. Finally, timer triggers are flexible. They can run every hour, every minute, or even multiple times per day. They are not limited to a single daily execution, which means you can schedule tasks as frequently as your workflow demands. Question 40. A team builds a .NET 6 application and wants it to run automatically when the container starts. They also want to ensure the correct runtime is included without manually installing it. Which Docker file instruction ensures both requirements are met? Select one answer. A. Use from to set a .NET runtime image and command to specify the application entry point. B. Use workdir to install the .NET runtime and copy to start the application. C. Use expose to install .NET and run to launch the application. D. Use copy to choose the runtime and from to start the application. The correct answer is A. Now let's go through the explanation. First, the from instruction is what selects the base image. In this case, choosing a .NET runtime image ensures the application has the correct runtime built in without any manual installation. Next, command is what specifies the command that should execute when the container starts, allowing the application to run automatically. Meanwhile, workdir and copy do not install runtimes. They simply set directories and move files, so they cannot ensure the correct runtime is present. Likewise, expose only opens network ports and run executes commands during build time, not at container startup. Finally, copy cannot choose a runtime and from cannot start an application. So by combining from for the runtime image and camid for the entry point, the container meets both requirements. Question 41. Match each Azure Container Instance's restart policy to its correct behavior. Each item may be used once, more than once, or not at all. The container is restarted every time it stops. Correct match, always. The container runs only once and never restarts. Correct match, never. The container restarts only when it exits with a non-zero status. Correct match, on failure. This policy ensures a container runs at least once. Correct match, on failure. This policy is the default when no policy is specified. Correct match, always. Now that we've gone through all the questions and answers, let's explain them. First, the always restart policy means the container will start again every single time it stops. This is also the default behavior, so even if you don't set a policy, Azure will assume you want the container to keep restarting. This makes sense for workloads that must remain continuously available, such as API services. Next, the never policy does the opposite. The container runs once and never restarts after completion. This is ideal for tasks like data migration jobs or one-time batch processing, where repeated execution would cause problems. After that, the on-failure policy restarts the container only when it exits with a non-zero status. In other words, it restarts only when something goes wrong. This also ensures that the container runs at least once. For example, a job that processes messages from a queue can use this policy to retry automatically if it encounters an error. Altogether, these policies give you control over how containers behave in production, allowing you to balance reliability, efficiency, and workload requirements. Question 42, for each statement below, indicate whether the answer is true or false. Azure container instances are stateless unless an external volume is mounted. True. The NAS DNS name label used during deployment must be unique within the region. True. Azure Files volumes can be mounted by both Linux and Windows containers in ACI. False. YAML deployment is preferred when deploying multi-container groups. True. Now I'm going to explain these answers. Azure container instances lose their file system state unless you attach an external volume, so persisting data requires Azure Files or another external storage option. Next, DNS name labels must be unique within the region because Azure assigns them to a public FQDN, and duplicate names would cause conflicts. Moving on, Azure Files mounts currently work only for Linux containers in ACI, which is why the statement claiming Windows support is false. Finally, YAML is preferred for multi-container groups because it lets you define all containers, shared resources, and configuration in one clear, reproducible file. Question 43. Fill in the blanks by selecting the correct options from the drop-down menus. Dapr components provide a pluggable abstraction for connecting to external services, and the set of components loaded by an app can be limited using application scopes. I will explain these answers now. To begin with, Dapr uses a pluggable abstraction so developers can connect to external systems like message brokers, state stores, or secrets engines without tying the application to a specific vendor or technology. This keeps the app portable and flexible. Furthermore, application scopes allow you to control exactly which components an app is allowed to load, ensuring cleaner separation between workloads and preventing components from being unintentionally shared across services. Consequently, this combination of pluggable abstraction and application scopes helps developers build modular, secure, and maintainable microservices that only load the components they actually need, keeping systems efficient and predictable. Question 44. Which statement describes how identity provider selection works in Azure Container Apps? Select one answer. A. You must configure exactly one provider per application. B. Only Microsoft Identity Platform can be enabled at a time. C. Identity providers must be selected based on the container image type. D. You may offer users multiple identity provider options simultaneously. The correct answer is D. You may offer users multiple identity provider options simultaneously. Now, let's explain this. When working with Azure Container Apps, authentication is flexible. Rather than locking you into a single provider, the platform allows you to enable several at once. This means a user could sign in using Microsoft Entra ID or GitHub or Google, depending on what you configure. Consequently, this creates a smoother and more inclusive login experience for applications that serve different user bases. Conversely, you're not restricted to one provider. And you're certainly not tied to the container image type because identity configuration happens at the environment level rather than the container itself. So in practice, enabling multiple providers gives your users choice while keeping your authentication setup centralized and manageable. Question 45. The Microsoft Authentication Library is used for which purpose in the Microsoft Identity Platform? Select one answer. A. To configure applications in Azure Portal. B. To register custom authentication providers. C. To acquire tokens for authentication and authorization. D. To create passwordless sign-in policies. Correct answer C. To acquire tokens for authentication and authorization. I'm now going to explain this so it's easy to understand. MSAL's entire job is to help applications securely obtain tokens that allow them to access Microsoft APIs or any API protected by Microsoft Entra ID. Because of that, acquiring authentication and authorization tokens is exactly what MSAL is built for. In contrast, configuring applications in the Azure portal happens through the portal interface, not MSAL. Registering providers isn't handled by MSAL either. It works with the identity providers already set up. And passwordless sign-in policies are created directly in Entra ID, not through MSAL. So C is the only option that matches MSAL's real purpose. Question 46. A development team is building an app that needs to support customers signing in with their social media or local accounts. The team wants to manage these identities separately from the company's internal directory. Which identity service should they choose? Select one answer. A. Microsoft Entra External ID. B. Azure Active Directory. B2C C. Microsoft Entra ID. D. Microsoft Identity Platform Endpoint. Correct answer. Azure Active Directory. B2C. Now I'll explain. Azure Active Directory B2C is the service built specifically for applications that must support social logins or local consumer accounts. It creates a customer-facing identity system that stays completely separate from the organization's internal directory. Consequently, companies can manage consumer identities independently while still keeping the corporate directory secure. Additionally, Azure AD B2C integrates easily with providers like Google, Facebook, and Twitter, making it ideal for public-facing apps. In contrast, Microsoft Entra ID is designed for internal organizational identities. And Microsoft Entra External ID manages partner or B2B identities, not consumer accounts. Finally, the Microsoft Identity Platform Endpoint only issues tokens. It is not an identity management system. For each type of service principal, drag it to the correct description. Each item may be used once, more than once, or not at all. Represents a global application object within a single tenant. Correct match. Application. Created when a managed identity is enabled and can't be modified directly. Correct match. Managed identity. Represents older apps created before app registrations existed. Correct match. Legacy. I'm now going to explain these answers so everything is clear. Application refers to the local instance of a global application object. In other words, when an app is registered, each tenant gets its own service principal tied to that global object. This is why the first description maps naturally to application. Meanwhile, a managed identity automatically creates a service principal behind the scenes. Because Azure manages it completely, you can't modify that service principal directly. Consequently, this aligns with the description about being created automatically and not editable. Finally, legacy service principals come from older systems. Before modern app registrations existed, apps had service principals without the rich metadata we have today. Therefore, any description referring to older apps points to legacy. Everything links together so you can distinguish the three types cleanly when working with identity in Azure. Question 48. Which of the following authentication flows allows applications on domain-joined computers to acquire tokens silently without user interaction? Select one answer. A. Implicit grant flow. B. Device code flow. C. Username password ROPC flow. D. Integrated Windows Authentication, IWA. Correct answer? Integrated Windows Authentication, IWA. Now let's go through the explanation. To begin with, IWA works silently because domain-joined or Entra-joined machines can request tokens on behalf of the user without prompting them. The user is already authenticated at the OS level, so no interaction is needed. Meanwhile, the implicit grant flow is an old browser-based method and still requires user interaction, so it cannot run silently. Additionally, the device code flow always asks the user to enter a code on a separate device, making it the opposite of a silent experience. Finally, The ROPC flow directly handles usernames and passwords, which not only requires input but is also discouraged due to security concerns. So, IWA is the only flow designed for seamless, silent token acquisition on trusted, domain-joined machines. Question 49. For each statement below, indicate whether the answer is true or false. Before initializing an application, it must first be registered in the Microsoft Identity Platform. True. The with authority method can specify both Azure Cloud and tenant information. True. In MSAL.NET 3.x, applications can only be configured through code, not configuration files. False. With client secret and with certificate can be used together for enhanced security. False. Now let's move on to the explanation to understand why each statement is correct or incorrect. First, an application must be registered so that the identity platform can provide essential parameters such as the client ID, tenant ID, and authority, all of which are required before initialization can occur. Next, the with authority method is capable of defining both the Azure Cloud environment and the tenant information, allowing the app to authenticate against the correct authority endpoint. Furthermore, MSAL.NET 3.x supports configuration through code and configuration files, which means the idea that it only works through code is incorrect. Lastly, with client secret and with certificate cannot be combined. They are mutually exclusive authentication methods, and attempting to use both triggers an exception rather than enhancing security. This structured approach helps ensure secure and predictable authentication behavior across applications. Question 50. Arrange the following steps involved in constructing a working signed URI for a storage resource using a SaaS. Identify the resource's URI, for example, the blob or container URI. Create the SaaS token by specifying parameters such as permissions, start and end times, and then signing. Append the SaaS token to the resource URI to form the complete signed URI. Now let's move on to the explanation so you can see why this order is required. First, identifying the resource URI comes before anything else because the SaaS you generate must be tied to a specific blob, container, or file. Without knowing the target resource, you can't produce a valid signature. Next, the SaaS token is created by defining the permissions you want to grant, the validity time window, and the cryptographic signature. This step is essential because it determines exactly what clients can and cannot do with the resource. Finally, appending the SaaS token to the resource URI produces the complete signed URL that clients can actually use. This final URL contains both the location of the resource and the temporary access rights encoded inside the SaaS. In real-world scenarios, this process allows you to grant limited, time-bound access to files without exposing your storage account keys, which keeps your environment secure and flexible. Question 51. Fill in the blanks by selecting the correct options from the drop-down menus. When copying objects between storage accounts, a SaaS is required to authorize access to the source object. A SaaS may be used optionally to authorize the destination object. Now let's move on to the explanation to understand why each answer is correct. First, when you copy data across storage accounts, Azure must verify that you have permission to read the source object. That's why a SaaS token is required for the source. It ensures the copy operation can access that object securely. Next, using a SaaS for the destination is optional because not all scenarios require it. Some destination accounts may already trust the caller through existing permissions or identity-based access. However, when destination access isn't granted through identity, a SaaS can still be added to authorize writing the copied data. Overall, this design provides flexibility. Azure protects the source by requiring explicit authorization, while still allowing multiple ways to validate access to the destination, depending on the security model in place. Question 52. Which statement correctly describes scopes in the Microsoft Identity Platform? A. They are encryption keys for protecting application tokens. B. They represent Azure subscriptions granted by administrators. C. They are string-based values representing permission sets requested by an app. D. They are static URLs used only by Microsoft Graph. Correct answer, C. They are string-based values representing permission sets requested by an app. Now let's move on to the explanation so we can understand why this is the correct choice. Scopes in the Microsoft Identity Platform are essentially permission strings that define what level of access an application is requesting from a protected resource. For example, an app requesting calendars. Read is asking permission to read a user's calendar through Microsoft Graph. A. The idea that scopes are encryption keys is incorrect because encryption and permissions are entirely separate functions. Scopes never secure tokens. They describe access needs instead. B. Scopes also do not represent Azure subscriptions. Subscriptions are billing and resource containers, while scopes are purely about authorization. D. Although scopes can appear as part of Microsoft Graph endpoints, they are not static URLs. Rather, they are permission identifiers that apply across many different APIs. In real-world application development, scopes help ensure apps only request the minimum permissions needed, supporting secure and least privilege access. Question 53. For each Azure Key Vault container type, drag it to the correct capability description. Supports storing software-backed keys, HSM-backed keys, secrets, and certificates. Vault supports only HSM-backed keys. Managed HSM Pool provides full certificate lifecycle features. Vault does not support storing secrets or certificates. Managed HSM Pool. Now let's move on to the explanation so you understand why each match is correct. First, Vault is the most flexible container. It supports software keys, HSM-backed keys, secrets, and certificates, which makes it suitable for most general-purpose secure storage needs. Moreover, Vault enables full certificate lifecycle operations, such as issuing, renewing, and managing certificates, so it correctly appears in 2 of the statements. Meanwhile, Managed HSM Pool is designed specifically for high-security hardware-backed keys. It cannot store software keys, secrets, or certificates. This is why it matches the statements about supporting only HSM-backed keys and not supporting other object types. In practical use, organizations choose Vault when they need versatility and select Managed HSM Pool when strict hardware-backed key protection is required for compliance or cryptographic security. Question 54. An engineering team wants to centralize sensitive information such as API keys, application passwords, and certificate data. They also want a logical boundary, so each application stores its sensitive values separately. Select one answer. A. Store secrets directly inside the application's configuration file. B. Use a vault as a logical group to contain application-specific secrets. C. Use local machine environment variables for all secrets. D. Store secrets in a shared spreadsheet accessible to the team. Correct answer. B. Use a vault as a logical group to contain application-specific secrets. Now let's move on to the explanation to understand why this is correct. To begin, using a vault creates a secure, centralized boundary that keeps each application's secrets isolated while still providing strong encryption and access control. This ensures that API keys, passwords, and certificate materials are not exposed in code repositories or stored in unsafe places. Next, storing secrets directly in configuration files is unsafe because these files often end up in version control systems, which significantly increases the risk of leakage. Even when encrypted, they lack the lifecycle management and audit capabilities a Vault provides. Similarly, relying on local machine environment variables ties sensitive information to individual devices, which not only complicates management, but also weakens security due to inconsistent controls across machines. Finally, storing secrets in spreadsheets is highly insecure, as it bypasses all formal access management and encryption practices. In real organizations, this type of storage is a common root cause of accidental exposure incidents. Therefore, using a vault provides the intended logical separation, centralized protection, and secure lifecycle management required for sensitive application secrets. Question 55. A company has multiple virtual machines that need to access the same secure resource, and the VMs are frequently recreated during scaling operations. Their permissions must always remain consistent without reconfiguration. A. Use a system-assigned managed identity. B. Use a user-assigned managed identity. C. Use VM-stored passwords for each scale event. D. Create a new service principal each time the VM is recreated. Correct answer: use a user-assigned managed identity. Now let's move on to the explanation so you can understand why this answer works. First, a user-assigned managed identity remains independent of any single VM. Consequently, even when virtual machines are recreated during scaling, the identity stays intact and continues to provide consistent access to the secure resource. Next, relying on a system-assigned managed identity wouldn't help here because that identity is deleted whenever a VM is deleted, meaning the permissions would break every time scaling occurs. Furthermore, storing passwords inside the VM introduces unnecessary security risks and requires constant rotation, which becomes unmanageable in dynamic scaling environments. Lastly, creating a new service principal for each VM recreation adds heavy administrative overhead and makes it nearly impossible to maintain consistent permissions across machines. In real-world scenarios, user-assigned managed identities are the preferred approach when multiple, frequently recreated resources need stable and continuous access to the same secure service. Question 56. For each statement below, indicate whether the answer is true or false. Managed identities are special service principals that can only be used with Azure resources. True. A system-assigned managed identity continues to exist after its parent resource is deleted. False. A user-assigned managed identity can be shared across multiple Azure resources. True. Managed identities require developers to manually store and rotate credentials. False. Now let's move on to the explanation to understand why each statement is correct or incorrect. First, managed identities are indeed special service principals created specifically for Azure resources, meaning they cannot be used outside that scope, which is why the first statement is true. Next, a system-assigned managed identity is tied directly to its parent resource. Therefore, when that resource is deleted, its identity is deleted as well, making the second statement false. Furthermore, user-assigned managed identities can be attached to multiple resources simultaneously, which allows them to persist even when individual resources are recreated, so the third statement is true. Lastly, managed identities remove the burden of manually storing or rotating credentials entirely, because Azure handles token issuance automatically, making the final statement false. In practice, using managed identities simplifies authentication, enhances security, and eliminates the risks associated with handling secrets manually. Question 57. Fill in the blanks by selecting the correct options from the drop-down menus. A virtual machine requests managed identity tokens from the endpoint at 169.254.169.254, and this endpoint is accessible only from within the virtual machine. Now let's move on to the explanation to understand why these answers are correct. First, the IP address 169.254.169.254 is the fixed metadata service endpoint that Azure VMs use to request managed identity tokens. It never changes and doesn't require configuration. Next, this endpoint is intentionally accessible only within the virtual machine, meaning it cannot be reached from the public internet or external networks. This ensures secure, local-only token retrieval. Furthermore, limiting access to the VM itself prevents attackers outside the machine from making token requests, reinforcing identity isolation. In practice, this design ensures that each VM can securely obtain temporary access tokens without the need for stored secrets or exposed credentials. Question 58. For each statement below, indicate whether the answer is true or false. A user-assigned managed identity can authenticate a blob client using default Azure credential options. True. The blob client example requires passing the managed identity's client ID into default Azure credential options. True. Blob client cannot use managed identities for authentication. False. Specifying a user-assigned identity requires providing the VM name instead of a client ID. False. Now let's move on to the explanation to understand why each statement is correct or incorrect. First, a blob client can authenticate using a user-assigned managed identity, because the default Azure credential can be configured with the specific client ID, allowing Azure Storage to validate and issue tokens seamlessly. Next, passing the client ID is indeed required when choosing a specific user-assigned identity, since Azure needs to know which identity to use when multiple are available on a VM or app. Furthermore, the idea that blob client cannot use managed identities is incorrect, because Azure Storage fully supports both system-assigned and user-assigned managed identities for secure token-based auth. Finally, specifying a user-assigned identity doesn't require the VM name at all. What matters is the client ID associated with the managed identity, which uniquely identifies it across Azure. In practice, using managed identities with blob clients simplifies security because it removes credential maintenance while still allowing precise identity selection when needed. Question 59. A product team wants to activate a new beta feature only for customers in a specific region without redeploying the application. They want to dynamically evaluate each request and decide if the feature should run. A. Use a feature flag with a filter that checks geographic location. B. Deploy a new application version only for users in that region. C. Hardcode the region list inside the application code. Store the region list in environment variables and restart the app each time. The correct answer is A. Use a feature flag with a filter that checks geographic location. Now let's move on to the explanation to understand why this answer is correct and why the others are not. First, choosing a feature flag with a geographic filter works because it evaluates every request dynamically, which means the feature can turn on or off for specific regions instantly without redeployments. This gives teams the flexibility to roll out changes safely and target specific customer groups. Next, deploying a new application version for each region would be slow and inefficient, and it defeats the purpose of feature management, which is meant to avoid repeated deployments. Furthermore, hard-coding the region list inside the application prevents any form of real-time updates. Every change would require another code deployment, which is both risky and time-consuming. Lastly, storing the region list in environment variables forces the application to restart whenever the list changes, which disrupts availability and still doesn't support true dynamic evaluation. In practice, using a feature flag with filters gives the team full control and ensures the beta feature activates only for the intended region, while keeping the system responsive and easy to adjust. Question 60. Fill in the blanks by selecting the correct options from the drop-down menus. Customer-managed key encryption requires the app configuration store to authenticate to Key Vault using a managed identity, while securing network access is achieved by configuring a private endpoint. Now let's move on to the explanation to understand why these answers are correct. First, a managed identity is used because it allows the app configuration store to securely authenticate to Key Vault without storing credentials, which keeps the wrap and unwrap operations protected and automatic. Next, securing access with a private endpoint ensures that traffic to the configuration store stays inside the Azure backbone, preventing exposure to the public internet and maintaining strict network isolation. Furthermore, alternatives like load balancers or routing tables do not provide authentication or encryption support, making them unsuitable for this security requirement. Finally, while firewall rules can add restrictions, they are not the primary mechanism for securing service-to-service communication for customer-managed keys, which is why private endpoints are the correct choice. In practice, combining managed identities with private endpoints creates a secure and streamlined approach for customer-managed key operations in Azure.